Hello and welcome back. In this lesson, we are going to do a practical on the stack frames. So let's get started. I've already created a new program, 74-stackframe.exe. So you should do this as well. How I did it was just to key in this code. So push 5 is over here, push 3 is over here, call add numbers is over here. So call this address. This is in the code cave, by the way. So if you double click on this, I use this address for the child function 402.7.2705. Your case might be different, so just do what you have on your PC. So this one is 402.7.5 is referring to this one. This add numbers is actually an address, and it's referring to this address here. So for me, it's this address. So in the function which is inside the code cave, I just key in all this. Push EBP, move ESP EBP, sub ESP4, move EBP plus 8, and add and so on. So all this is inside the code cave. So now I'm going to run this, and before that I put a breakpoint. So I put a breakpoint here already, and I'm going to run. So watch what happens to the stack. So at the start of this program, the ESP and EBP is in the original location down here. So watch what happens when I push 5, what happened to the stack. And also you can watch here. So for this you must change this. Originally the default is like this. Change it to std EBP stack so that you can see the arguments for the function here. You have to run it first. Okay, so it hits the breakpoint. Now it's going to push 5. 5 is on the stack, and just incidentally, EBP is pointing to the base of the previous stack, which is here, 64 FED4, which is here, 64 FED8, which is here. So this was the EBP stack before the main function is run. So now we have pushed 5 to the stack. Now we're going to push 3, and now you see 3 is on the stack. Now you're going to call the function. So when you call the function, okay, let me update this. So ESP is now here and here. ESP is pointing to the first argument. So now you are going to enter the call. So when you enter the call, it's going to push the return address to the top of the stack, and the return address is this address, this one here. So let's step into the call, and now the return address is pushed into the stack. So now your ESP has gone up another D word up here. Now you're going to do all this, push EBP. So you're going to save the present EBP by pushing it onto the stack. This is necessary so that you can later come back to the original location for EBP inside the stack. So this is the current location of EBP pointing here. Now you're going to push this and save it on top here. So let's step over, and now you see the current location of EBP is already on the stack for safekeeping, so that we can come back to it later. And your ESP will move up another D word. So now ESP is pointing here, and below that you have all the return address, you have the first argument and the second argument, and so on. So now next thing to do is you're going to move your ESP to EBP, so that EBP will now take its new position in a newly created stack frame. So you're going to step over this, and now you notice what happens to EBP. EBP is now same as the ESP. Both of them are now pointing to the same location, which is at the top of the stack. So this thing goes up here, like this. Right, take a look. Here you go, EBP. Now EBP is currently set up. The stack has been created. The stack frame has been created, and now EBP is pointing to the base of the new stack. Alright, so now we are going to sub 4 from ESP because we want to create one local variable. So it's sub 4. If you want to create 2 local variables, then you must sub ESP 8. And if you want to create 3 local variables, you must sub ESP 12. So 12 would be C in hex. So in this case, you only want one local variable, so you sub 4. Notice what happens when you do that. Step over that, and now you see ESP has gone up again by 4 bytes. And the default value for it is null. Nothing there, it's all zeros. So this is a new variable, a D word. You just created it by doing this. So now ESP is pointing to the top, but EBP remains unchanged. it will not change, and that's why it is useful, because it can use to reference the function arguments as well as the local variables. Now we're going to reference the first argument of the function argument. So the first argument is this one. To reference it, you must do EBP plus 8. Remember, earlier on I have this EBP plus 8 refers to the first argument. EBP plus 12 refers to the second argument. Okay, so that's what we are doing here. So we are going to refer to EBP plus 8. You can also see here EBP plus 8, EBP plus 12. So this is the first argument, EBP plus 8. Second argument is EBP plus C, and so on. So now we're going to move this to EX, step over, and now the value 3 has been moved to EX. 3 is inside the first argument. Next, we are going to add the second argument to EX. So EX is here, EBP plus C is the second argument, and we're going to take that second argument, which is 5, and add it to EX. Step over, and now EX becomes 8. Then we are going to move this result 8 into our local variable EBP minus 4. EBP minus 4. Remember, when you're accessing the function arguments, is plus. When you're accessing the local variables, is a minus. Take a look again. EBP plus means you're accessing the function argument. Those are the arguments which was pushed to the stack over here. Push to the stack before you call. Those are function arguments. So to access them, you must plus. But when you do a minus, it means that you're accessing the local variables, those variables which are created temporarily inside the function. Then you minus. That's a convention. So here you are accessing the local variable because it's a minus, and here it doesn't show it. This only shows the function parameters, the function argument. It doesn't show the local variables. For local variables, you have to look here, right? This is the local variable. Yes, EBP is pointing here. EBP is pointing to FEC8. EBP is pointing here, FEC8. So if you are going to access a function argument, you must plus 8 for the first argument, plus 12 for the second argument. If you are going to access the local variable, then you must minus 4 for the first local variable and minus 8 for the second local variable. So in this case here, we are accessing the first local variable, so you minus 4, and then you assign 8, which is inside EX. So you assign 8 to EBP minus 4. So take a look what happens here when I step over this code, and 8 goes over there because it came from EX. Now we are going to move the result into EX. Although this is just redundant, but you need to know this because in many programs which you disassemble and view, it will always do this. Store the result from EX to location memory. It will always store it back into EX, although it's redundant. So in this case here, you have to move the value stored in EBP minus 4 back to EX, because by convention, every function call returns the results in the EX register. That is a convention. That's why we have to do it here as well, although it's redundant. So let's step over that now. And EX now has got the result of the function call. Then now you're going to destroy or undo the stack. To undo the stack, you just do the reverse of what we do up here. So now you're going to move EBP into ESP. So EBP move into ESP means that you destroy the local variables, and you make ESP point to the top of the new top of the stack, which is here. So now let's step over this and watch what happens to this ESP. Step over, and now ESP has gone down by 4 bytes. See that? Previously it was here, now you go here. That means you destroy the local variables by doing that. Although it's not really destroyed, it's still there in memory, but it's not being accessed anymore because you already move it down by 4 bytes. So you can do ESP now is pointing here, the new top of the stack, like this. So now both EBP and ESP is pointing to the top of the stack, and now we are ready to pop this because ESP is pointing to the top of the stack. When you pop whatever is on the top of the stack, we pop into the argument. In this case, the argument is EBP. So you pop EBP means you're taking the old value of EBP and putting it back into EBP. That has the effect of moving EBP down to the original location. So let's take a look now at EBP. EBP now is at the top here somewhere. EBP is FEC8. FEC8 is here. So when you do this, you pop EBP. Now EBP has moved from, so EBP goes back down here. FED8. FED8 is down here. See that? So EBP now points to the original location it was pointing to before all these calls were made. So now ESP will move down by 4 bytes because of the pop. EBP will be down here by now. Then ESP will go here. Now okay, so now we're going to read. So return, remember when you call a return, it will pop whatever is up here, and this will be the return address. You will pop this into EIP so that you can go back to the main code, this line. Let's do that now. So we step over read, and notice now we go back to main function, right? And then the last thing you need to do is you need to clean the stack. So now after you have already called read, ESP will be here. ESP is now pointing to the first argument 3. Now you have to clean the stack. So to clean the stack, you have to add 8 to ESP because there are 2 function arguments, 1, 2. So you have to add to it so that it will go down to here. So let's step over, and now ESP goes down by 2 DWords, 4 bytes here and 4 bytes here, 2 DWords. And you can see over here now 3 and 5 now has been destroyed because you have moved ESP down to the location it was in prior to the call. So this was the state of ESP and EBP before the call was made. So now you have restored everything to the stack. You have destroyed the stack frame. So this is how stack frames are created, used, and dismantled in the assembly code. Make sure you save this file as 74-stack-frame.ext. Now before we close this, I'd like to tell you a shorthand. Now instead of writing the code like this, instead of writing move EBP to ESP and pop EBP, you can use one single line like this, leave. So replace these 2 lines with one single instruction leave, and it does the same thing. So sometimes in this assembly code you will see this, sometimes you will see this. So both are correct actually. For example, if you scroll up to our EIP here, you notice our original code push EBP. You look at the bottom, you find leave here, LEAVE. See? So when you create the stack frame, you push EBP, move ESP to EBP, and then when you dismantle the stack frame, you do the reverse by calling leave. And this one single instruction leave can replace these 2 lines here. So this is another thing you should be aware of. Sometimes you will see leave, and sometimes you will see these 2. So both you need to know to understand what is happening in the code. So that's all for this video. Thank you for watching.